This is GATE 2011 question number 35, which states that a system of n non-interacting and distinguishable particles of spin 1 is in thermodynamic equilibrium. What will be the entropy of the system? So the entropy of the system in this kind of a feature where n non-interacting and distinguishable particles are there with spin 1, we need to find out the entropy of the system, and these are the four options. So let's see how to proceed with this particular question. So this is the given condition is that the system having n non-interacting and distinguishable particles with spin 1, this is important, and n particles, that is important. So there are total n particles and with spin plus 1. Now we need to find out what? The entropy of the system. That is what the question asks. We already know that S is equal to Kb log omega. According to the statistical mechanics, if you do certain derivations, we will get this particular result, that is entropy is related to the omega, where omega is the number of microstates, which tells us about the microscopic properties of the system. So here it is defined, S is the entropy of the system, Kb is the Boltzmann constant, and omega are the number of microstates, which represents the microscopic properties of the system. Now, the relationship between omega and spin S is given by omega is equal to 2s plus 1 to the power n. This is a very popular relationship which relates the amount of spin with omega if there are n non-interacting particles. Therefore, omega is equal to 2s plus 1 to the power n is the formula which we will be using for this particular question. It is given that the spin having amount spin 1, therefore omega becomes 2 into 1 plus 1 because spin S is nothing but 1 in this case, so it will be 3 to the power n. So omega, number of possible microstates, when this kind of a configuration is there where n non-interacting particles with spin plus 1 is there, we get this as 3 to the power n. Now that becomes n kb log 3 because 3 to the power n, this is a property of logarithm that when you have in power something in power, then that power comes as a product. So n kb log 3 will be my answer for this particular question, which is nothing but the entropy of the system. So entropy comes out to be n kb log 3. So the correct option is D. N kb log 3 is the correct option for this particular question. Thank you.